Math 3, Unit 9, Module 4, Part 2, Lesson 4, Day 1. Today's lesson focuses on developing the unit circle and then being able to identify the sine and cosine of different values given in degrees and radians using the unit circle provided. So before we dive into the unit circle, a little review of trigonometry. SOHCAHTOA stands for sine, so the S in SOHCAHTOA stands for sine. The O stands for opposite, as in the opposite side of a right triangle. Opposite meaning the side of the triangle that is opposite the reference angle. H stands for hypotenuse. Hypotenuse is the longest side of a right triangle. It's always across from the right angle. C stands for cosine. That's another trigonometric function, just like sine is a trigonometric function. The A stands for adjacent, and adjacent means next to. The H stands for hypotenuse again. And then the T stands for tangent, and tangent is a trig function as well, just like sine and cosine. So tangent is equal to the opposite side over the adjacent side. So basically these three trig ratios are defined as the ratio of two of the sides of a right triangle. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Looking at number 2, there are these things called special right triangles. There's a 30-60-90 special right triangle and a 45-45-90 special right triangle. So in a 30-60-90 right triangle, there's a certain ratio to the sides. They're related to each other in a certain way. So across from the 30-degree angle is called x, across from the 90-degree angle is called 2x, and across from the 60-degree angle is x root 3. In a 45-45-90 special right triangle, there's also a relationship between the sides. Across from both 45-degree angles is x, across from the 90-degree angle is x root 2. And then that last triangle is another 30-60-90. It's just that now the 60-degree angle is in the lower left corner. So they just flipped the 30 and the 60. So across from 30 is x, across from 90 is 2x, across from 60 is x root 3. Now the reason we had these little special right triangles here is to help us sort of see how this unit circle is developed. So let me show you the whole unit circle and then I'll zoom back out. So a unit circle is a circle with a radius of 1 unit. You start right here when you look at the unit circle, and then you always go this direction, so counterclockwise when you look at it. So on this unit circle, you have measurements in degrees. So for example, 0 degrees, 30 degrees, 45 degrees, and so on and so forth. So those are degrees. Then you have measurements in radians. So for example, pi over 6, pi over 4, pi over 3, those are measurements in radians. So the 30 and the pi over 6, those are equivalent measurements. It's just that one is in degrees and one is in radians. We had learned back in lesson 3 how to convert between degrees and radians. The numbers out here on the edge, these are x, y coordinates on the unit circle. So you'll notice there's an x-axis and a y-axis, like a normal xy coordinate grid that you would graph a line or a parabola on. So the root 3 over 2 and the 1/2, those are xy coordinates. Those are points on the graph or on the grid. So what happens is, let me show you where these numbers come from that are on the outside of the circle. We're going to do that by looking at those special right triangles and how they relate to the unit circle. So I'm going to look at this blue first triangle right here. I'm going to look at that first, but on the unit circle. So I'm taking this triangle and I'm just jotting it down right here. So on that blue triangle, this is the 30-degree angle, this is the 60-degree angle, and this is the 90-degree angle. So we had said across from 60 was x root 3, across from 30, x root 3, I can't see it, x root 3, and across from 30 was x, and across from 90 was 2x. So what happens is, from these trig functions back up at the top here, sine is opposite over hypotenuse. So if I look at this 30-degree angle, and I consider this 30-degree angle my reference angle, if I want the cosine of that, I have to do adjacent over hypotenuse. So again, if I want the cosine of a 30-degree angle, I need the adjacent side, which means next to, so x root 3, over the hypotenuse. So the hypotenuse would be right here. So this is the hypotenuse, and this is the adjacent side. So x root 3 over 2x. When you simplify that, you get root 3 over 2. So root 3 over 2, you'll notice, is right here. So that's where that root 3 over 2 comes from. It's the cosine of the 30-degree angle. If I look at that same triangle, but now I talk about the sine of 30 degrees is opposite over hypotenuse from those trig ratios up at the top of the notes. So opposite is x, and then hypotenuse is still 2x. So the x's cancel out, and you get a half. And sure enough, that half is right here. So what happens is, when you're looking at the coordinates on the outside of the unit circle, the x-coordinate is the cosine of the angle. The y-coordinate is the sine of the angle. So let me put that over here. So this is cosine, and this is sine. And it's like that for all of them. Now, you'll notice this little example I just did is also true for the 45, 45, 90 triangle and for the 30, 60, 90 triangle oriented the other direction with the 60-degree angle. So that's where these other numbers on the unit circle come from. For the sake of time, and because I'm not going to officially test you on this part of the unit circle, I'm going to skip going over the 45, 45, 90 and the other 30, 60, 90 with the 60 as the reference angle. But just realize it would be like what we were doing right here. So it would be the same process. It's just that this blue triangle I drew, I would draw, this 45, 45, 90 triangle, or I would draw this one with the different reference angles. If you're super duper curious to know how that all works, just shoot me an email or a Canvas message, and I can try to do a little video of me doing the explanation for the other two triangles. So to kind of sum it up, the big thing you want to get out of this unit circle is that all of these coordinates on the outside of the circle, those are all the cosine and sine values of the different angles. So for example, and actually, sorry, one last thing. The really, really easy way to remember this, it goes in alphabetical order. So X comes before Y in the alphabet, and then with sine and cosine, C comes before S in the alphabet. So the X coordinate is always the cosine of the angle, the Y coordinate is always the sine of the angle. And we can find these values using the degrees or using the corresponding radians. Why don't we do a couple examples so you understand what I'm talking about? So if you scroll down to this next problem here, it says we want to use the information on the unit circle to find the exact values of the trigonometry expressions below. So maybe we can do the first 6 or so, and then I could let you try the rest and just check the answer key later. So I'm looking at part A. It says sine of 45 degrees. So 45 degrees. So you look at your unit circle and you find 45 degrees. So I'm looking right here. There's 45 degrees. So at 45 degrees, just slide your eyes out to these points right here. And they asked us for sine. So if we look back at our little reference right here, we know that the sine has to be the y-coordinate. So the y-coordinate that corresponds is right here, root 2 over 2. So like that's it. You just write down root 2 over 2. So if you scroll back down to part A, your answer would just be root 2 over 2. That's literally all you do. Looking at part B, they want cosine of 300 degrees. So you go to your unit circle, find where it says 300 degrees. So that happens right here. And then look at the x, y coordinates that correspond to that point. So just slide your eyes right out here to these x, y coordinates on the outside of the unit circle. They had said to find cosine. So cosine is always the x coordinate. So 1/2. So if you slide back down here, you literally just write 1/2. Let's do a couple more. So looking at letter C, they want cosine of 30 degrees. So find 30 degrees on the unit circle. So right here, cosine is the x coordinate of the numbers out on the outside of the unit circle. Cosine is always the x coordinate. Remember, it goes in alphabetical order. X is cosine, y is sine. So you just jot down root 3 over 2. Root 3 over 2. For part D, it says cosine pi over 2. So you still tackle this problem the same way. It's just they gave us a radian measurement for the angle instead of a degree measurement. So we're looking for pi over 2. So pi over 2 is right here. And I already forgot if it was sine or cosine. Cosine is what they want us to find. So cosine is the x coordinate. So right there, 0. So slide back down and you write down 0. Let's do 2 more. So sine of 5 pi over 6. So we have to find 5 pi over 6 on the unit circle. There it is, 5 pi over 6. And then they wanted sine. So sine is the y-coordinate. So 1/2. And then last but not least, cosine 45 degrees. So 45 degrees is right here. And we wanted, I think it was sine. Nope, we wanted cosine. So cosine 45 degrees. Cosine is the x coordinate. So root 2 over 2. Root 2 over 2. So why don't you try out the rest of the problems on this worksheet, and then you could just check the answer key that I'll post a little bit later. Real quick, going back to unit circle, again, just remember the starting point for the unit circle is right here. So you basically start right there at 0 degrees or 0 radians. So 0 degrees or 0 radians. You go counterclockwise all the way around, and then you end at 360 degrees or 2 pi radians. So basically all the way around a circle is 360 degrees, which you know back from math 2. And then all the way around the circle is 2 pi radians. And remember, all those degree measurements and radian measurements that are next to each other, they're equivalent to each other. You just do those unit conversions back from lesson 3 to see that those are indeed congruent or equal to each other. Not congruent, equal to each other. And again, all these coordinates around the outside of the circle, the xy coordinates, all the x's are the cosine values of the corresponding angles. All the y values are the sine values of the corresponding angles.